And I want to welcome you to the Enterprise Integration Summit Expert Breakout Sessions. This is the session for Neuron ESB, and let me welcome back our two great speakers, Manoj Talreja and Marty Woznicki. Gentlemen, welcome.
Thank you.
Thanks again.
In his position as a development manager at Neuron ESB, Manoj Talreja looks out for new architectures and features to add to the Neuron ESB, and we're going to hear about some of those this morning. He is a full-stack engineer and experienced developer and brings 13 years experience in developing applications and integrating business systems. And it's going to come in totally handy at today's session as we get through both the content and an upcoming demo. And for his part, Marty Woznicki, Vice President, spearheads the Neuron ESB.NET-based innovations to address digital business integration needs. He has 22 years experience in enterprise software and integration and is a veteran of Microsoft's Connected Systems division and knows a lot about distributed technologies. In their session, using Neuron ESB and Docker to develop and deploy microservices, we're going to find out just exactly how the modern day approach to ESB is really starting to open up opportunities for using microservice architectures and containers to build, deploy, and integrate applications faster than ever. In particular, we're going to learn how Neuron ESB can help simplify many of the complex steps that goes along the way, creating a microservice architecture, virtualizing a service or an app, and even give developers self-service capabilities. And I hear we'll even get a demo of how Neuron ESB can Dockerize service endpoints. Just before I hand it over to Manoj and Marty, let me remind you, you can download today's slides and get a host of white papers and other downloads. Just click any of the links under the viewing area, all without any extra registration, by the way. And to connect with Marty and Manoj, just type in the submit a question box. We'd love to make this interactive where we can. And so now, Manoj, let me turn it back to you and tell us about how to use Neuron ESB and Docker to develop and deploy microservices.
Thanks, Vince, for a great introduction. I have Marty with me. We are going to talk about how to use Neuron ESB and Docker to develop and deploy microservices. Let's talk about our agenda first. In this session, we're going to talk about Neuron ESB and microservices design principles. Then we will drill down into how to use Neuron ESB and Docker to more quickly implement microservices in your organization. And we'll do a sneak peek and demo. We'll create a microservices in Neuron ESB and run them using Neuron Container in Docker. Let's start with introducing microservices. What exactly is a microservices? Back in 2011 in Venice, a group of software architects met to discuss about latest design patterns to build scalable services. And they coined the term called microservice. Above, a statement from Martin Fowler captured the spirit of microservices accurately. He said that the microservices architectural style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanism, often an HTTP resource API. So Neuron does that. In a nutshell, microservices is another variant of SOA. It is more or less use the same design principle. Today, microservices is synonym to scale. All big companies are developing their product by applying microservices principle, which help them scale based on their increasing demand of the product. In this next slide, we're going to talk about how Neuron is really great engine to build microservices. Neuron has been built on principle of SO and microservices. Hence, it tries to build microservices-based API. In Neuron today, you can create REST or SOAP services, but now you can build the API, but you can control the deployment aspect of it as well. You can define it to run within Neuron or run as a fully independent service. You can scale in and scale out this Neuron API based on your consumption. For example, you realize that certain API used heavily, you can easily scale out and load balance them. Or you can specify in policy to spin up new instances of API based on CPU or memory usage. One of the major advantages of using microservices architecture is that you can run them independently. Hence, say if you're running hundreds and thousands of these things using Neuron and running them independently or in a small set of them independently, then in case of outage of a specific service or API won't affect the entire system. Also using Neuron, you can build an API which is built for a specific domain and have only single responsibility. It is a small unit of service which does a specific thing. These are basic principles of microservices, and you can achieve all that using Neuron today. So I will hand over to Marty talking about Neuron ESB.
Okay, so let's spend a few minutes on what Neuron ESB brings to the table for microservices and how some ESBs, most notably Neuron, have actually evolved over the years into full-blown integration brokers. First, let's take a moment and think about some of the challenges companies face today. A lot of them have multiple systems that do a variety of things like HR, payroll, supply chain management. Many have cloud apps in the mix now like Salesforce, Dynamics, NetSuite, and Workday. They may be involved in acquiring other companies that have their own systems and manual processes. They may even have legacy systems that aren't integrated into their newer customer platforms. In any case, most want a 360-degree view of their business as well as their customers, and they want it in near real time, not the end of the week, not using batch processes. When they reach that state, they find that they can make better and more timely decisions that directly impact their bottom line. Hence, the goal of integration brokers is to eliminate the spaghetti of unmanageable connections that most companies have to deal with today. Now, as we previously noted, some ESBs, like Neuron, have evolved into full-blown integration brokers, shipping with pub-sub messaging systems, graphical business process automation tools, long-running workflow, as well as service and API mediation hosting capabilities. For example, Neuron can host API and SOAP-based services. Developers can create microservices directly through our UI. No code required to create, host, or monitor them. In turn, they can use the built-in connectors to expose existing systems to the rest of the world as APIs or microservices. They can use the built-in workflow and business process automation tools to turn their business requirements into real capabilities. These features allow Neuron ESB to tie systems together pretty quickly, acting much like a universal translator. They can be used to automate processes, provide service composition capabilities, and reduce the overall development effort. They also allow organizations to abstract their back-end processes, systems, and services from all of their consuming client-facing applications so that they can make changes quickly without impacting customers. As we can see, Neuron ESB ships with all the necessary features to make integration and microservices a reality. Using Neuron's upcoming release, microservices can be deployed in their own dedicated host environment and Dockerized. Now, Manoj, our Neuron ESB development manager, will take over the rest of the presentation, focusing on using Neuron ESB to create microservices and then using Docker to deploy and scale those microservices. Manoj, take it away.
Thanks, Marty. We're going to talk about design principle of Neuron ESB microservice architecture. Typical on-premise microservice architectures look like this. Using Neuron, you can define your API contract. Using business process and workflow feature, you can implement your API. And you can assign your API to run under Neuron ESB host runtime. You can specify queues there, and then eventually all these things are running into a Windows as an individual process, or as in call as an independent process. Let's talk about Docker and why it was important for us to build and run Neuron packages as a container. We had a feature in Neuron where you can install multiple instances of Neuron on the same machine or different machine. And although it will let you install multiple instances of Neuron, you have to make an adjustment like enabling a port sharing or change the ports for a specific instance. And we had customers come to us and tell us about all those issues which they are facing. So we listened to our customer on a number of issues when they have to run and install multiple instances of Neuron. And we came up with Neuron container approach. I believe containerizing Neuron with Docker solves the multiple instance issues because each container runs on its own virtual private network. So what is a container and what are the benefits? We're going to talk about that. Containers are like lightweight virtual machines. It has its own file system. It contains base operating system and other bare minimum things to run your software. While creating an image, you choose what kind of operating system we're going to run our software on, what kind of independent software we need to pre-package, and how they will be reconfigured. We store them in private registry where user can download it and customize the container based on their need. For example, if some other product is using Neuron ESB for messaging, then they can use Neuron container and package it with their product or project. In a nutshell, if we use container to package our software, they are guaranteed to run as is in any other machine. And the microservice architecture with container looks like this. Again, you will define the API contract using Neuron Explorer, and you will put the business logic using business process and workflow process. They are going to run into a Neuron ESB, and this Neuron ESB is going to run under the Docker container. With that being said, I would like to jump into a quick demo and show you how easy to run microservice in Neuron container using Docker. This demo demonstrates exposing a dynamic CRM instance as a microservice. In this particular case, it is exposing the dynamic CRM account entity as a REST endpoint. For purpose of this demo, I'm showing you implementation of GET operations, but it can easily extend it to support post, put, and delete. These microservices can be combined with other microservices to seamlessly complete complex business operation across multiple business applications. So I will jump into my demo now, and I will show you running containers using Docker. So the first thing is that this is the Neuron Explorer editor. That's where you're going to design your API. Once you have defined your API, it basically generates an automatic configuration file for you. And what we are doing, we are actually internally using this tool to generate this configuration. This tool called Docker Compose, which is a wrapper around Docker API. Docker Compose tool is useful in running multiple containers together. In case of Neuron, we are using it because it is convenient for us to generate these files. Also in Docker Compose, we can store all API-related settings pre-filled. In my case, in the config file, Neuron Explorer, which is our developer editor, it has already set the ports for my service which it needs, the database which I'm going to use, and whatever the user and password I'm going to use. It's also assigned some ports. It basically picks up what exactly ports you're opening up and assign it to your adapter or client connector. So it does everything behind the scene. You don't have to write all these things. All it does, as soon as you create an API, it's just going to generate all those things automatically. Now, the coolest feature of Neuron Docker is the volume. So basically, you can use your physical directory, which is on your host machine, and you can share it with the container. So container is virtual environment. It's able to take your folder, which you are sharing here, into its environment. So that's what I'm defining here. So this is my API, which I already created, and I want to run into a Docker. So all I have to do is I have to call Docker Compose up. So as soon as I do it, it's going to take a few seconds because it has to spin up all these containers, and it's basically turning on the API. So before we test our API or look further, let's go back to the presentation and look for what exactly it did. So Docker Compose command resulted in starting 3 Neuron container. Neuron container is acting as a service broker. Then there is a Neuron container, which is turning on microservice API, which is a REST API. And basically, when the user calls this API, Neuron ESB service broker, which is again another container, accepts this message and it knows where it needs to send. So in case it is sending to dynamic CRM. So I have all these 3 containers up and running. And I can look at them, how they are running, by just writing a command called Docker PS. Using Docker PS, I can see it actually turn on 3 containers for me. In fact, it's 4 because we are also using a Neuron database. Now, if you look at this console here, you will see that I have a bunch of logs. And these logs are really helpful. What you can do is, if you're going to use Kubernetes just in case for managing your Docker, you can take these logs and take the output of these logs and fit it into tools like Zipkin, Sentry, and Grafana. And all these are open source tools, really great, and we're going to use some of them in our portal side. So with that being said, let me go and open a browser and let me call this API. So I'm going in browser. So basically the way I have defined my APIs, I'm saying it has to go to localhost. But just to make sure that this is working straight away from container, I'm going to take this IP address and I'm going to call my API from there. So here you go, and 8080, and I'm saying account. So this is going to go and going to talk to container, and it's going to bring me back the records from dynamic CRM. Now let's go and do a little more. What I'm going to do is I'm going to pass an account ID for the account, and I'm going to get the account details. So that works, right? So basically, in a nutshell, what happened, it's running 3 containers. One is for REST API, which is your microservice. And as I said, the basic principle of microservice is to basically, you can modify the application and deploy that application individually. With container, you can do that. We can also look at the things, what exactly these things are running using Neuron Explorer. So I can go into, just give me a second. Let me go here. So I'll take this IP address because that's where my main ESB service is running. And go in here, machine, just going to paste this, apply, save. And I'm going to activity screen, and I'm going to show you in the endpoint health, you will be able to see That's going to list out which are the 3 containers turned on. So it's turned on the container which is running a topic, then it turned on a container which is running a CRM 2013 adapter host, and it turned on endpoint host. Let's give you a real-time tracking what exactly happens. That's our monitoring story is today, but we are moving towards the portal, and that's where you will see a lot of features coming in. So with that being said, let's say I'm getting list of accounts and we say, that's fantastic. Everything is working cool. But let's assume at certain time during month or year, my API is getting hit hard because there is too much traffic and I need to scale. In order to scale, the traditional approach has been that you spin up another machine, which will run entire application. Although all we wanted was to scale an API because that's what's supposed to do heavy lifting. In container and using Neuron, you can scale that specific API in a matter of seconds. All you need to do is write following command using Docker Compose. Docker Compose up -- scale CRM web hook endpoint host equal to 3. And let's look into the picture what exactly this command is doing behind the scene for me. So behind the scene, what it did, it created the 3 instances of the same API, which is again talking to Neuron ESB service broker, and the messages are again going to CRM. But what you can do as well is you can put the load balance in front of it. You will be able to do more requests using this approach. And I can show you in action how you can hit this different APIs using IP address. So I'm going into this 3rd instance of it, and I can go in here and I can paste this and just going to run an account. I'm just going to call an account API, and it's basically running, right? So it's basically hosting. It's created 3 instances of it, and all of this is up and running, and I can hit against all this API. If I have a load balancer in front of it, I could use a round robin policy and a bunch of different policy in order to make sure that my container is using at its full capability. So in case if unexpected crash happened with my API or adapter, it will only affect the container which is causing the problem, not the entire system. All this command which I have wrote in using a Docker Compose in PowerShell, you don't have to do that. When you are using Neuron Explorer to deploy and manage these things, you don't have to write all these commands. That will be straight away done through the Neuron Explorer UI, where you will be able to do these things. And you don't have to have knowledge of Docker too much, but you have to have minimal knowledge of Docker, and most of the things you will be able to do it through our Neuron Explorer. And to conclude my demo, I'm just going to go back to my slides and going to describe a little bit more about how Neuron and Docker works really well together. So Neuron container using Docker. Neuron can be deployed as a container using Docker for Windows. We use Docker for Windows to containerize our Neuron. You can use Neuron container in Docker to run on-premise, and you can manage them on-premise using Neuron Portal and as well as Neuron Explorer. Neuron Portal is our web portal, and that's where you will be able to manage all these things from there. But we're also going to give us some support in Neuron Explorer as well. You can also run Neuron container in cloud using various cloud vendor like Azure's Container Service, Docker Swarm, Docker Data Center, and in future, we have plans to support Kubernetes, so you can run that in GKE as well. In summary, here I'm going to talk about what we learned today. So in a nutshell, Neuron containers in Docker works really well and can provide any organization greater flexibility and ease of use. As we've seen in demo, using Neuron, you can create microservices, and you can also deploy it using container. Based on your usage, you can spin as many containers you want, provided you have enough hardware. Since microservice runs under Neuron, there is always a need to talk to other services, but instead of talking to them point to point, you can talk to them using Neuron ESB capability. That being said, that concludes our presentation, and I will hand over to Vance if he has any questions for us to answer.
Excellent, excellent. Manoj, Marty, a really eye-popping look at the world of Docker and microservices from the point of view of an ESB or an integration services broker. Really terrific session. And I think it kind of is opening some new lines of inquiry and some new possibilities for our attendees. So a really great session.
Well, thank you very much.
Thank you.
You know, guys, it was so provocative. In fact, I wonder if we could just take a step back and level set a little bit about the thinking that went into bringing Neuron ESB platform into this world of microservices and containers. I think a lot of our attendees think of ESBs as a really great, well-proven technology for traditional integration, but they don't necessarily think about it as something that could help them with app development in this new world. Could you walk us through your thinking, and what are people missing about the architecture of Neuron ESB?
Well, sure. For the most part, I think a lot of ESBs out there have just kind of like remained stuck in the past, so to speak. I like to think that we've evolved, and we try to evolve every year and every day with our technology. Our goal is to try to make software development, and integration, and service interaction easy for customers. We don't want them to have to go out and have to sign multi-million-dollar SOWs for consulting work just to tie their systems together. And services are becoming more and more and more of reality for customers. Customers are moving to the cloud. They're integrating their APIs. They're building APIs. They want to go to a microservices architecture, and we believe that building a platform that enables that works for us and works for them.
And Manoj, from a development manager point of view, give us a sense of how you connected the dots between delivering on that vision Marty just talked about, between making an ESB kind of microservices and container ready, if you could.
So ESBs is not only for integration developer, it's for general developer as well. It's really important when you start building your small idea or concept around things which you want to do using your API, that can lead to certain things which you don't know right now, but maybe in future you might have 10 other things which you want to send this data from, which you are collecting from API. So it's very important as a developer to have that platform which is proven. The ESB is proven, and over the time it's really helpful. But using microservices and Docker, it's going to give a lot of benefits in long run. That's what I think about this aspect.
It's a really great vision, because you suggest to me, and the questions kind of suggest it too, that in this new world of composite applications, bringing microservices and APIs together for either the UX of what the customer experiences or how the different components of an application work together, such as in some, pretty famous composite applications like an Uber or something, that we really are kind of in a new world of needing brokering. And that to some extent, whether the developer thinks about it or not, he's really going to be doing a lot of calls that will require some level of brokering between these different microservices. Is that a good way to think about it?
Yeah. And also, I just want to add another point is, like, today, nobody's doing container-based integration, right? Everybody is just going traditional approach. They are just think that I'll just create an API and do the point-to-point. But that's where ESB brings a lot of value. And as I said, nobody's doing in the market today integration based for the containers. That's what our forte is right now.
It's really interesting about this too. Historically, developers would really have to be responsible for developing their solution in such a way that it would scale and so that it would perform. But now, really think about it. With Docker, you can actually put that back into the purview of the network operations guy. If somehow your microservice isn't scaling enough, your network ops guy, all he's doing is spinning up a new container instance of that microservice.
Fantastic. Let's talk a little bit about the demo, Manoj. Someone noticed that they kind of made the comment, I didn't see too much coding going on in any of the demo. There were some basic command line functions, but not what I would consider to be very in-depth coding. How much do I need to know about Docker or microservices to use Neuron ESB?
That's a great question. With Neuron, we are bringing the capability so that we don't have to learn Docker as much. All this happens behind the scene. If you look at the Docker itself, most of the time people are only using command line because it does that thing automatically for you. And we are bringing another level of automation using Neuron. With Neuron, you don't even have to type all those commands going forward in future. So that's where we are heading towards now. The world is changing. There's not a lot of coding you need to do to achieve this complex thing because there are tools out there which can do it for you.
Another point came up, guys, and that is the idea of just kind of looking at the actual product form factor or the different components that went into the solution. And the question here says, I got the impression that there were multiple features or multiple even individual products that were being demoed here. Could the speakers please detail the different pieces that go in to this Neuron ESB solution for Docker and microservices?
So for building API or defining API, we're using a Neuron Explorer, and those things runs in the Neuron ESB runtime. And we are containerizing it, all this Neuron containers using Docker. We are using two main technologies in there. One is Neuron specific, and the other thing is we are using Docker. Microservices out of the box in the Neuron. You don't have to do anything for that.
Neuron ships with a number of technologies, capabilities out of the box, and that's certainly service hosting, process management, process automation, workflow, messaging, just a number of things, connectors for different systems. But we also ship a hosting environment for all this. And mostly everything is just done through configuration, right directly through the UI, the Neuron Explorer, which Manoj shared.
Fantastic. And I know, Manoj, I had noted here that you had also mentioned something called the Neuron ESB Portal. Give us a few words about that.
So we are taking a lot of capabilities which we have already in the Neuron Explorer to Neuron Web Portal. And it's going to look really cool. You can manage like hundreds of environments just from the portal itself. It's done really well.
So one of the things that we're doing is we're launching the new Neuron hybrid technology platform, something that is in addition to the Neuron ESB platform, completely backwards compatible with Neuron ESB. So you'll be able to use that web management portal to manage everything in the Neuron ESB environment. But it is web-based, a lot of monitoring capabilities, a lot of operational capabilities, as well as things like alerting and scheduling, service API management over time.
Oh, fantastic. In the minute or two we have left, guys, I just wanted to give you this opportunity to talk about the convergence between the integration world and the app world and how Neuron's latest technology is bridging those two.
Well, unlike a lot of ESBs, we've always had a focus on development and the developer. We've always wanted to make their life easier. That's one of the reasons why we've stayed on the .NET platform. We've integrated .NET into our platform. Developers can write code easily, can deploy things. We've tried to make it very easy so they don't have to worry about doing all the hard things around concurrency and scaling and deploying and threading. We want them to be effective and do what they enjoy doing. But we also want to make sure that we're adopting a lot of the patterns, the technologies that they enjoy using, that makes them better developers, and that can help organizations build these applications that can get out the market a lot faster. Our goal with Neuron has always been faster time to market, not just for the company, but also to make developers more agile in their activities.
It's a great perspective, and it's certainly something that I think our audience is going to really benefit from, because integration is certainly a DNA and an enabler for many things. And in this particular session, we've seen another dimension of that. But before we go, just a quick word: how would folks engage and learn more about Neuron ESB? Give us a sense of what people should do next.
I'd love it if people would go to our website, www.neuronesb.com, visit our site, take a look at some of the capabilities we offer, and they can go up, read our articles. They can actually download an evaluation copy of our software for free, 30 days, try it out. They can reach out to our support team, and we'll help them through anything they might need.
Fantastic. And with that time has expired, Manoj Talaraja, Development Manager, and Marty Woznicki, Vice President at Neuron ESB, thanks again for a terrific session, and I think an eye-opening one about the role that integration technologies is playing in this new frantic search for ways to deliver apps faster and better. Really great session.
Well, thanks for having us.
Thank you.
And as we love to do here at the Enterprise Integration Summit, we know that we want to facilitate your education there among the attendees. So here's a slide with some extra information that we weren't able to fit into the breakout room directly here. It'll take you to some great web-based resources that Marty was speaking of. And we also, don't forget, have a copy of the slide deck this morning, as well as some other terrific PDF material for you available right now, without registration required. And we also have a link to that evaluation copy Marty referenced. Thanks again, everyone.